Hello children, welcome to online class. Today's subject is Geography of class 9th and the topic is Motions of the Earth. Children, you have learnt in the first chapter about the solar system. You know that Sun is at the center and Earth along with other planets moves around the Sun. In this chapter, you will learn about the motions of the Earth, that is rotation and revolution. First, we'll discuss about rotation. Now, what is rotation? Rotation is the spinning of the earth on its axis. Now, what is axis? Look at the diagram. This is the axis of the earth. It is slightly tilted. Now, if a line is drawn at the center, the axis makes an angle of 23.5 degree. And there is you can see the line, horizontal line. It is parallel to the plane of the orbit. And the axis makes an angle of 66.5 degree. That means the earth is tilted in position and this is called inclination of the earth. So rotation is the spinning of the earth in an inclined position. Next we will learn about the characteristics. First is duration. The earth takes 23 hours, 56 minutes, 4.09 seconds to make a complete rotation. What is the direction? The earth moves from west to east. Then speed. Speed is 1660 kilometers per hour. Position. The position is inclined. The earth rotates in an inclined position. So these are the characteristics of rotation. Next, you will learn about the effects of rotation. Now look at the diagram. This is the earth. The portion which faces the sun has day and the portion which is away has night. So due to rotation, days and nights occur. Now you see this diagram. These are the rays of the sun and you see the duration of day is not same everywhere. You see this is the northern hemisphere which is tilted towards the sun. Now the duration of day increases from equator to north pole in the northern hemisphere and beyond the Arctic Circle there is 24 hours daylight. But in the southern hemisphere the duration of day decreases from equator to south pole and beyond the Antarctic Circle there is 24 hours darkness. This is because of the rotation of the earth in an inclined position. Another effect of rotation is due to rotation, a centrifugal force is created and because of that there is a bulge at the center and the poles are slightly flattened. You have learned in the other chapter that the shape of the earth is not a perfect sphere. There is a bulge at the center and the poles are slightly flattened and this is called oblate spheroid. It is because of the rotation. And because of rotation, the wind and the ocean currents turn to the right in the northern hemisphere and they turn to the left in the southern hemisphere. And because of rotation, the earth rotates from west to east. And because of this, the sun and the moon appear to rise from east and they set in the west. Another effect is the time is not same everywhere on the earth because of rotation of the earth. A very important point is that you know that the portion where there is day, it gains heat constantly. And the other side, which has night, it loses heat constantly. Now, because of the short rotational period, that is only 24 hours, because of this short rotational period, the difference between day temperature and night temperature is moderate. This is because rotation of the earth. Now, next you will learn about revolution. What is revolution? The movement of the earth round the sun on a fixed path is called revolution and the fixed path is called orbit. The orbit is not spherical in shape, it is elliptical. Now, what are the characteristics? Speed. The speed is 1 lakh kilometer per hour. Now, the orbit is elliptical in shape. That is why the distance of the Earth from the Sun varies. The maximum distance is 152 million kilometers and minimum distance is 143.3 million kilometers. Now, because of the speed of revolution is not uniform. Why? Because of the elliptical shape of the orbit. When the Earth is closer, due to gravitational pull, the Earth moves faster. So the speed is not uniform every time. Because of revolution, leap year is caused. Now, what is leap year? Leap year is a year where there are 366 days. Now, generally, a year has 365 days and 6 hours. But do we write 6 hours? We don't. Now, this 6 hours, this is added every 4th year to the calendar. That means 6 into 4, 24 hours are added to the calendar. That means a complete day. That makes the number of days in a leap year 366. And this extra day is added to the month of February because February is the shortest month. So leap year has 366 days. Now, you have learnt about the speed of rotation as well as revolution. The rotation speed is 1660 kilometers per hour and revolution speed is 1 lakh kilometer per hour. But do we feel the motion? We don't feel the motions. Why? First reason is the force of gravity keeps everything attached to the Earth. Second is Newton's first law of motion. What is this Newton's first law of motion? According to this Newton's first law of motion, a body remains at rest unless an external force is used. Okay, next you will learn about the effects of revolution. Now look at the diagram. Due to revolution and the spherical shape of the Earth, heat zones are formed. See, from 23.5 degree north to 23.5 degrees south, this area receives vertical rays of the sun throughout the year. So this area is very hot and it is the torrid zone. Beyond this, that is 23.5 degree north to 66.5 degree north in the northern hemisphere, and from 23.5 degrees south to 66.5 degrees south in the southern hemisphere, these areas get slanting rays of the sun. That is why the temperature is moderate. So it is called temperate zone. Now beyond this, from 66.5 degree north to North Pole in the northern hemisphere and 66.5 degrees south to South Pole in the southern hemisphere, these areas receive extremely slanting rays of the sun throughout the year. So these areas are very cold and it is frigid zone. Now we have learned, because of revolution and the spherical shape of the Earth, different heat zones are formed. Now look at the diagram here. Because of the elliptical shape of the orbit, the distance of Earth from the Sun is not same. Now, when the Earth is closest to the Sun, that is on January 3rd, this position is called perihelion position. Now, January is winter, but it is closest to the Sun. Then why? Because the northern hemisphere is tilted away from the Sun and the southern hemisphere is tilted towards the Sun. That is why, though January is winter, Earth is closest to the Sun. Perihelion position. Now, July 4th, this is called aphelion and is farthest from the Sun. July is hot. Though it is farthest, it is hot. Why? Because now the northern hemisphere is tilted towards the Sun and southern hemisphere is tilted away from the Sun. So July 4th, aphelion position, farthest from the Sun. and January 3rd, perihelion position, closest to the sun. Now, because of revolution, different seasons occur. Now, I will explain 4 different positions of the earth. Now, look at the diagram. 21st June, summer solstice. On 21st June, vertical rays of the sun fall on Tropic of Cancer and the northern hemisphere is tilted towards the sun, and there is summer in the northern hemisphere. This position is summer solstice. Now see the southern hemisphere. Here the southern hemisphere is tilted away from the sun, so there is winter. 21st June, there is summer in northern hemisphere, winter in southern hemisphere. Now you see the duration of day. Duration of day increases from the equator to North Pole, and beyond the Arctic Circle there is 24 hours daylight. But in the southern hemisphere, duration of day decreases from equator to South Pole, and beyond the Antarctic Circle there is total darkness. So this position is called summer solstice, 21st June. Now look at this position. 22nd December is called winter solstice. Now the northern hemisphere is tilted away from the sun and southern hemisphere is tilted towards the sun. The direct rays of the sun fall on Tropic of Capricorn. Now you see the duration of day in the northern hemisphere, it is decreasing from equator to North Pole, and beyond the Arctic Circle there is total darkness, 24 hours darkness. But in the southern hemisphere, the duration of day is increasing from equator to South Pole, and beyond Antarctic Circle there is total daylight. So this is winter solstice position, 22nd December. There is winter in northern hemisphere, summer in southern hemisphere. Now there are 2 equinoxes. Look at this. The vertical rays of the sun fall on equator, and there is equal day and night throughout the earth. Everywhere there is equal day and night, and this position is called equinox, and the day is 21st March. That means on 21st March, vertical rays of the sun fall on equator. But the season is, in the northern hemisphere, the season is spring, and the southern hemisphere has autumn. Now another equinox. Again, the vertical rays of the sun fall on equator, but the day is 23rd September. This time also there is equal day and night throughout the earth. But the season in northern hemisphere it is autumn now, and in the southern hemisphere it is spring. So you have learned that there are 2 equinoxes. Equinox is equal day and night. Equi means equal, nox is night, that is equal day and night. So on 2 days, that is 21st March and 23rd September, vertical rays of the sun fall on equator. That is why throughout the earth there is equal day and night. And there are 2 solstices, that is summer solstice, 21st June, vertical rays of the sun are on Tropic of Cancer, and 22nd December, winter solstice, vertical rays of the sun are on Tropic of Capricorn. And on 21st June, summer is in northern hemisphere, winter in southern hemisphere, and on 22nd December, some winter in northern hemisphere and summer in southern hemisphere. So these were the effects of revolution. That is all for today, children. Have a good day. Take care.